Lesson 6-8, Systems of Inequalities. Our essential question is, how do you solve a system of inequalities? A system of inequalities means more than one inequality. And I'm going to clarify that by saying more than one linear inequality. The solution to a system of inequalities is the region shaded by both or by all of the inequalities. First, you see a little bit of review right now. This simply says graph the inequality, and there's only one inequality here, so this is not a system right now. This is just one inequality. So as a little refresher, to graph this inequality, we start out at the intercept of 1, and then we use the slope. 2 over 1 means rise 2, run 1. I'm going to continue in both directions to fill the entire coordinate plane. And then I need to remind you that when we look at the symbol here, the less than or greater than symbols, remember those were dashed lines, and the less than or equal to, greater than or equal to were solid lines when we learned how to graph our linear inequalities. So this line needs to be a dashed line for me. So I'm going to go with my line drawing tool and go with my dashed line. And then my symbol is a less than. So less than means that I'm going to shade below my line. So below my line is going to be the right-hand side here. And I can plug in a test point to make sure that I've shaded correctly. So here's my original inequality. My test point, I'm going to go with, let's say this point right here. This point is 2, 1. So x is 2 and y is 1. I'm going to check and make sure that this is true. 2 times 2 is 4, plus 1 is 5. 1 is less than 5 is true. So I have shaded the correct side of this inequality. So this is a review of graphing one linear inequality. Another one for review, what happens when it's just y is greater than or equal to 3? Well, on the y-axis here's 3. All of the points where y is equal to 3 would lie on this horizontal line. Remember, when the only variable that we see is y, it's going to be a horizontal line. Every point, if I put points all over, every one of these points has a y coordinate of 3. Now my symbol, because this boundary line would be y equals 3, my symbol says y is greater than or equal to that 3, so I'm shading up above. That region has a y coordinate that is greater than 3. Greater than or equal to includes the line, so that's why I did a solid line for my boundary line. So greater than or equal to, solid line shaded above. This next one, if it was just an x coordinate, x is less than or equal to 5. This one has only an x-intercept of 5, no y-intercept. This is going to be a vertical line. Every point on this vertical line, every one of these points has an x-coordinate of 5. Every one of them. Now this symbol says less than or equal to, so less than would be to the left of that line. So this would be the region. Remember the shaded region. Every ordered pair, everything in that shaded region is a solution to that inequality. Okay, now we have a system. So we're going to graph and shade 2 of them. And the region that's shaded by both of them is going to be our solution set. So my red inequality has an intercept, a y-intercept of 2, and then it also has a slope of 2. So up 2 over 1. Looking at the symbol, it would be a dashed line. So I need to go with a dashed line because it's just a less than symbol. Change the color so that it matches. Okay? And this one would be shaded because it was a less than, we would shade below. So below this line, I'm going to shade over here. Okay. Now, my other line is going to be blue. I am going to put a 1 in front of that x before I make it a fraction. So the blue line starts at an intercept on the y-axis of -3, and the slope is -1/1, so down 1/1 to the right. So here's my blue line. This is going to have a solid line because it is greater than or equal to and greater than or equal to would be shaded above. So I'm going to shade up above like this, and you should be able to see the region that was shaded by both of them. That region is our solution set. So when the two lines intersect with each other, there are 4 sections. 4 sections formed. One section is shaded only once. Another section, sorry about that, one section is not shaded at all. The next 2, so the ones that I labeled 2 and 3, those are shaded once. So section 1 is not shaded at all, section 2 is only blue, 3 is only red, so it's this section 4 that is shaded twice. Any points in that doubly shaded region are solutions. So I am going to go with my favorite ordered pair, 0, 0, and I'm going to show you that if I substitute 0, 0 into both of my equations, it's going to be true. So my first was y is less than 2x plus 2. So if I put 0 for x and y, 0 is less than, well, 2 times 0 is 0, plus 2, so 0 is less than 2, true. So that one checks. Then I'm going to substitute in my other one. 0, 0 again. Well, the opposite of 0, or -0, is just 0. 0 minus 3 is -3. 0 is bigger than -3. True again. So the region that I've shaded twice is the correct solution. The next system, my red equation starts at 1. Slope is -3/1, so down 3/1. It's a solid line because it had an equal sign underneath the symbol. And it is greater than or equal to, so greater than or equal to would be shaded on this side because it's above the line. My second one, less than or equal to, intercept is -2. The slope is the same. It's going down 3/1. So, what's going to happen on this one? We have parallel lines here. I'm going to draw my line. Now remember, this one's a less than or equal to. So less than or equal to this line would be below this line. So below this line would be shaded over here. So now, what region has been shaded twice? Nothing has. So that means that there is no solution. No solution. There is not an area that was shaded twice. There are three different regions when we're talking about parallel lines. There's a region in between them. This region in between them is not shaded at all. So the first part not shaded at all. Second and third region are each shaded once. There is no fourth region because the lines are not intersecting each other. So there is no solution. Okay, your homework assignment is just 6 problems. Take your time. Make sure that you plug in those test points so that if you have a region shaded twice, make sure that you check to see that a point in that doubly shaded region is true when you substitute it in both of your inequalities.